topic called subset we started. So the definition, A is said to be a subset of B if every element of A is also an element of B. So there are a few things, few symbols we had learnt. What are they? A subset symbol. What is the symbol for subset? So there is the U written horizontally, and when it is not a subset, what is the symbol? Okay, not a subset. Then there is another symbol, double implication. This symbol is double implication. So already you studied in a previous paragraph where it is using the symbol, this one word, one-way arrow. One-way arrow after we are is equal to and a right arrow. It stands for the word implies. Implies means conveys the same meaning. It conveys the meaning. Same way. Then comes the double implication. So double implication means two-way implication. That means the statement on the left, the statement on the right, they will imply one another. They will imply each other. The right side statement will mean the left side statement will mean the right side. So that is called double implication, but we don't read it as double implication. It is usually read as IFF, if and only if. In short, you can also use IFF, if and only if. Don't think if that appears, this word appears, don't think it's a spelling mistake. In mathematics, it is not a spelling mistake. It conveys the idea if and only if, which is already symbolically then another symbol, which is double implication symbol. And another important property, every set is a subset of itself. For example, A is subset of A itself. And empty set has no element. So empty set is also a subset of every set. Read up. So two new points we have studied today, this morning. So I want you to place your attention and note down these points which are very important properties. So what is that? Under subset, you would have made the definition for it, the symbol for subset, symbol for not subset, then the meaning of double implication, the next point. The next point, every set is subset of itself. That's an important property. And another, in the next point, you are supposed to make note that empty set is a subset of every set. Empty set is a subset of every set. So then, NCERT, they are giving you some example. We can go through it. Let us go through the example. Point number one, the set of rational numbers. The set of rational numbers is a subset of set of real numbers. So you can write Q subset or Q symbol for rational number set, uppercase or symbol for real number set. Then if A is set of all the divisors of 56, B is set of all prime divisors of 56. Then you can write B is subset A. I would like to elaborate on this. Prime divisor of 56. Yesterday also I was talking to you about the 10th standard prime factorization principle. 56 is divisible by 7, the biggest prime number for 56. And once you divide by 7, then you are left with, yeah. So it is 8 times 7. 8 is nothing but 2 cubed. So this happens to be the prime factorization. So what is the prime divisor? I can only give you 2 prime divisor. So prime divisor, the set B, I want you people to identify what is set B. Set B is 2, 7 only. But when you talk about set of divisors, there are 8 divisors. So try, can we come up with all the 8 divisors? Beginning from 1 is a divisor, 2 is a divisor, not 3, 4 is a divisor, 7 is a divisor, 8 is a divisor. Then what else? 14 is a divisor, 28 is a divisor, also 56 is a divisor. So are you understanding how you will get 8 divisors? All these numbers divide 56, leaving 0 remainder. Is it not correct? 1, 2, 4, 7, 8, 14, 28, 56, 8 divisors completed. So now can you see this 2 and 7 is already present in A. So I can say the complete set B is present inside here, inside of A. So B is subset of A. That's what is mentioned here. Okay. So in case you are not able to understand in the set builder form given here, you make roster form, list pannungo. So 2, 7, list all the divisors of 56, there must be 8 of them. List, make a list. Then you understand which is subset of which one. I hope that is understandable for everybody. Then they have, in the third point, they have given A 135. It's a roster form. But B, it is given in set builder form. X is odd natural number but less than 6. So you are going to write odd number but less than 6, so 135. So actually the same set is appearing again. So A is 1, 3, 5. B is also in roster form 1, 3, 5. So you can say A is subset B also. You can also say B is subset of A. If that is the fact, then A is equal to B. Please make note, this is an important property. If one set, if each set is subset of each other, then those two sets must be equal. A subset B, B also subset A. It implies A is equal to B. So I can see in the chat dialogue, there is one request. Explain second point once again. Good. Good. What divisors of 56? All divisors, but set B is only prime divisor. So there is a difference, there is definitely a difference between all divisors and prime divisors. So prime divisors is easily obtained by doing prime factorization. How do you obtain prime factorization? Are you remembering? What are all the prime numbers you know? 2, 3, 5, 7, 11, 13. Now choose the go in descending order of prime number, not in ascending order.
Is it only 56 or can be?
Not coming up in ascending order. Go in descending order of prime number. 13 does it divide 56? 13 does it divide 56? Definitely no. So 11 does it divide? No. 7 does it divide? Yes. Choose it. Choose it. So write the biggest prime number. But 7 power 1 divides, not 7 power 2. 7 power 2, 49. 49 divide? No. Okay. 7 is chosen. Then, once you choose 7, you can check the quotient. When 56 is divided by 7, what is the answer it gives? 8. Now think of 8, not 56. Think of 8 only. 8, is it divisible by 5? No. Is it divisible by 3? No. But divisible by 2? Yes. Choose it. Now what power divides? 2 power 1 or 2 power 2 or 2 power 3? It's perfectly 2 power 3. So the prime factorization is over. And what are the prime numbers selected? 2 and 7 only. So B is set of prime divisor only. Yeah, tell me.
Should be only 56 or can be any number, sir?
Hey, question 56 இருக்கிறதுக்கு discuss பண்ணிட்டு இருக்கோம். Any other number naga you have to create a new question.
No, I am asking you, can we do it with any number?
You can do with any number, it will always be prime divisor,
Yes, sir.
subset of all divisors. Okay.
Yes, sir.
சரி, okay. B வந்து என்ன ஆகும்? It is 2, 7. So the prime number selected, that divisor is those divisors are forming a set. Yeah. Next, all divisor. Now all divisor is little bit tricky. You have to start from natural number set 1, 2, 3 and go on choosing all the divisors till 56. But you may say, sir, it is a very exhaustive job. I'll tell you a trick. Actually, when I was doing, I had a trick in mind. I'm doing it. Nalagavali, are you all focused? Are you interested in learning that trick? How many divisors I told you? I told you there are 8 divisors. All divisors. Before writing all divisors, I told you there are 8 divisors of 56. How did I tell you? It is not any astrological magic. This is nothing but look at the power of 2 and look at the power of 7. What are the powers? 3, 1. Yeah. Now, observe what I am doing. Add one more. Add one more. What do you get? 4 and 2. So that is to be multiplied. So that is how you get number of divisors for 56. Totally there are only 8 divisors. So once you got the 8 divisors, you don't have to be unsure. You need not go searching further. விட்டுட்டோமோ அதெல்லாம் நீ திங்க் பண்ண வேண்டியதில்லை. 8 divised, but surely you have to add. So if you have not completed 8, then you have to search for missing device. Are you understanding? And this is the same thing for any number. So now there was another doubt. This can be done for any number. Yeah, it can be done for any number. For example, I want to tell you what is 60. 60. What is the prime factorization for 60? Again, do the same listing. I'm sorry, not one. Prime number 2, 3, 5, 7, 11, 13, 17. Start from the largest. I told you go in descending order. Easily you can see the prime numbers 17, 13, 11. They are not dividing 60. Not even 7. Yeah, 5 divides. 5 divides. Once 5 divides, I told you take the quotient. Now quotient is 12. 60 by 5 quotient 12. Now try for 12. That's it. So 12 divisible by 3. Yes. Yes, divisible by 3. But 3 power what? 3 power 1 or 3 power 2. Yeah. Huh? Yeah, good. Good. Rakesh Rao has given the answer 2 power 2, 3 power 1. Yeah, 3 power 1 only. Now do the quotient. When 12 is divided by 3, what is the remaining quotient? 4 only. Divisible by 2, but power is 2. So, these are the factors, but then prime factorization ends in 2 and 3 and 5 are the only prime factors. But when you want to create list of total factors, now what you have to do, multiply the numbers, keep them ready. What are the powers, you keep them ready. But before multiplying, don't multiply that power. Add one more, add one more, add one more. So how many factors you find now? Divisors. So 3 into 2 into 2. So that becomes 12 divisors. So 60 has totally 12 divisors. After you go in search of all the 12, read that. So when you want to write the roster form, suppose I ask you for roster form of all the divisors of any composite number. Have this prime factorize, then take the powers and then add 1 to each power and multiply the results. So here what is the result? 3 times 2 times 2. That gives 12 divisors. And what are the 12 divisors? Let me list here. Starting from 1 is a divisor, 2, yes, 3, yes, 4, yes, 5, yes, 6 also, yes, 10, yes, 12, yes, 15,
15.
yes, 20, yes, then
60.
already you got 3, 6, 9, yeah, 10 over
30.
30 and 60 over 11, 10, 12. 12 divisors you completed. That's all. So you have to, before listing them, you must have an idea how many divisors are you going to search for. தெரியாம நம்ம வந்து இமேஜினேஷன்ல பண்ணிக்கிட்டே இருக்க முடியாது. How many? Okay. So once you know the number of divisors for sure, then listing is becoming easier. Right? Is that point number 2, is that clear? The point in your own interest, how can we find all divisors of a composite number? So, you're in 10th standard, you are doing the prime factorization. Now, something new, what I am giving you a shortcut is take the power take one more of all the power and multiply those numbers. So you get the number of factors. Then you can make your listing. So prime factors will be a subset 2, 3, 5. 2, 3, 5, yes, it is there. 2, 3, 5. It is a subset of all the factors. Any clear?
Yes, sir.
Okay. Point number 4. What is that? There is a set A, set B, A, E, I, O, U. Then there is set B, A, B, C, D. Surely we know A is not subset of B also. B is not subset of A also. Now, if A is subset of B and A is not equal to B, then A is called a proper subset of B. Not only that, B is called superset of A. For example, 1, 2, 3 is proper subset of 1, 2, 3, 4. But 1, 2, 3, 4, the B in turn is a superset of A. Yeah. This next sentence I have already mentioned yesterday. Any set having only one element inside, it is singleton. I already told you yesterday. Okay, they are giving you example and a set containing just a singular element. It's a singleton set. இது நம்ம நேத்தே பார்க்கிறோம் கவுண்டிங்ல எம்டி தென் சிங்கிள் தென் ஃபைனைட் அண்ட் இன்ஃபைனைட்ல பார்க்கிறோம்.
So the right function is still proper subset and superset.
So let me down. In number systems, subsets of set of real number. The set of natural number is subset of real number. The n, you can say n is actually subset of whole number also. N subset of rational numbers also. N is subset of real number set also. Yeah, integer also we can say it is subset of rational numbers also. Integer subset of real numbers also. Then comes rational numbers. Rational numbers you can say subset of real number. What else you can say? I am going to say now Q is superset of Z integers. How to write it? Very simple. You reverse it. The closed end is the sub, the open end is the super. U open end அப்படின்றது superset part and the closing end is sub around. So Q is superset of Z. Okay. So can be practiced easily. What else? So some of the obvious relation they have given you. The continuous subset n becomes subset of Z, Z becomes subset Q, Q becomes subset of R, and T subset of R. They have given you can name. Temporarily they gave set of irrational number denoted by T. So irrational number also subset R, but natural number not a subset of irrational number. Okay, so T set of irrational, they have given a temporary symbol. Then coming quickly down, you know already last week we were doing this as an introduction before we came to the proper lesson. Interval as to represent subset of, what do you mean by R? Real number. So even yesterday there was one doubt regarding, sir, okay, what is the interval? Interval is always when there is real number in discussion. Real number. Now, once again, so even if you had missed the session last week, now you can easily understand the interval. There is something called an open interval. Open interval means only using curved bracket. So curved bracket means that the ending number A, B do not belong to the interval. That means I told you A is not included, B is not included. அப்படி இருந்தா we use curved bracket, opening and closing. This is one point. Second point also you do closed interval. Okay, where the end point is included, அப்படின்னாக்க square bracket of AB. Okay, so that means both numbers A and B, they are included. It can be a mixed bracket. For example, on the opening side there is square, closing side there is curve. Meaning on the left side there is equal to inequality, there is a is equal to symbol, but on the ending side is equal to is not there. Governing. So includes A but excluding B. So you use square bracket on the left side when it is beginning. For the closing, it becomes a round bracket. Exactly opposite in the next point. Open interval of A, that means A is not included, N is equal to illai. But on the ending side B, there is equal to present. So it is square bracket. So these things we have done in last week's in solving this kind of inequality. Inequality. Okay, so I told you this will be useful in future. So definitely now it is you are learning it as part of set theory lesson. Also again you will be what using them in the proper inequality lesson. Okay, so intervals I need and number line, you see just a figure 1 1 1. This also I told you very important, using number line on real number line. How do you select interval? Okay, இது என்ன interval எங்க ஷேடிங் ஆயிருக்கு பாரு. A it is not shaded, அப்ப A is excluded, B excluded. Okay, here A is included and there is a dot is placed. நான் உங்களுக்கு வச்சு காமிச்சேன், dot is placed அப்படின்னா it is included. A dot is placed, included. Dot placed, included. A hollow dot, then not included. Hollow dot, not included. So you can see the blue shading. So it is A comma B. That's what the interval is also named here. And here both are included, square bracket A, square bracket B. And here it is square bracket at A and open bracket, the closed bracket B. So open interval of A, closed interval at B. So everything is depicted as I showed you the shading of real number line. Real number line, again and again you will keep coming back to the real number line. Okay. So interval நிறைய கேட்கிறாங்க. அதெல்லாம் நிறைய சால்வ் பண்ணிக்கலாம் இந்த மாடல். X இதுக்கு என்ன பண்ணி, for example, what is the interval for this? They have given you what is the interval for this solution set X belongs to, I told you, and -3 the left hand has is equal to symbol, and the right number, the right side number 5 does not have is equal to symbol. So -3 comma 5. But you should, all of you should focus. This is the method only when real number is discussed. When we are discussing real number, இப்போ இதுவே வந்து -3, x is greater than or equal to -3, less than 5, but x such that, but x is a natural number. See, look at the qualifier. Last week நிறைய இந்த பேசணும். Natural number qualifier பார்க்கணும். Qualifier, if it is a natural number, then all this interval is useless. Now you have to give the answer in the form of set. What number you will find in the set? I'm sorry, in natural number. You cannot begin at -3. You cannot begin at -2. The next integer -1. No. 0. No. Only 1 you will start. Yeah. So only this will be the answer. X is a natural number. Between -3 and 5, you will pick only natural number. Are you understanding? So there is a lot of difference in the qualifier. Qualifier is very, very sensitive. Rombo sensitive in governing. For example, I may have a 0, then 1, 2, 3, 4, 5. On the other hand, I can have on the left side, I can say there is -3, -2, -1. 1, 2, 3, 4. But I am supposed to choose only natural number between -3 and 5. So I will be only selecting 1 and 2 and 3 and 4. I cannot even go to 5 because equality symbol is not there. So I write these 4 elements as the answer. So you can see the number line will have only dots presented. You cannot go for this continuous shading like this. The mother shading panna mudiyadu. Shading and all comes, the bracket interval comes only when this happens. What happens? X is real number. Real number qualifier irukkanum, adha neenga gavanikkanum. Qualifiers are very important. So hope that's clear for all of you. So the qualifiers is a must to watch. Then the following discussion is a very interesting discussion. What is that? There is something called, there are 2 powerful titles there. Rendu title governing. One, the point number 1.7, power set. The next one, universal set. So these are very powerful concepts. I would actually deviate from textbook and I will give you a lot of explanation on the board. Just give me a 1 minute. Yeah. So power set. இதுல நம்ம நிறைய பேச வேண்டியிருக்கு. The power set. There is a definition part. You can make note of the definition. The collection of all the subsets of set A is called the power set of A. In P of A, every element is a set. Every element is a set. Consider the set. Now I am coming to the explanation. Consider the set 1, 2. Write down all the subsets of the set 1, 2. How can we do that? We know empty set is also subset of every set. So first thing is produce empty set. First thing done. Then the element 1 can be converted into a set. Element 1 can be converted into a set. You may not be very clear. So why should I convert 1 into a set? Okay, for that reason, let me, our discussion will happen here. Power set of a set. Set, let it be A, then the power set is denoted by P of A. So please make note, it is a collection, power set is a collection of all possible subsets. All possible subsets of A. What do you mean by all possible subsets? So you should know what are all the possible subsets. How many? The collection, how many? So note panning, what is the list? Number 1, empty set is a subset always. So collect the empty set first. Then you collect as many singletons as possible. What do you mean by singleton? Sets containing singular element. So you should pick, for example, if I have a set containing 1, 2, 3 in set A, you pick every element and make them a singleton set. That's why we make a set out of singular element 1, make a set out of singular element 2, make another set using singular element 3. Now singletons are completed. Empty set, very simple. There is a symbol, either this symbol or this kind of symbol. There is a phi symbol. Thirdly, collect all 2 element subsets. 2 element subsets, collect them. How it is possible to collect 2 element subset? Means start making pairs. How many pairs you can make out of this 1, 2, 3? This is done experimentally only. Okay, experimentally you can do. I can create 1 and 2 first. Clear? 1, 2, then 2, 3, and 1, 3. So 2, 3, and first and third. It's easy because you are having only 3 in front of you. 3 elements, 1, 2, 3. It will be a bit more complex if you have 5. So 2 element subsets, collect them. Then go for collecting similarly 3 element subsets. Similarly 4 element and all that. You go ahead and so on. You can say and so on. When you are done, for example, in this set, once I write 3 element subset, I am done, isn't it? What can you say about the 3 element subset? 3 element. Set A itself having only 3 element. Clear? The set A already has 3 element only. So 1, 2, 3 together is the 3 element subset, which is the set itself, which you have studied. Every set is subset of itself. So now you can collect all of them. So collecting all of them, what happens? You are writing the empty, then you are writing singletons, which are 3 in number, 3 singleton. Then pairing to be done, 2 element subset they are pairing, 1, 2, 2, 3 and 1, 3. So 2 element subset, it is over. Then all the 3 elements together, that is set A itself. Now you form a new set out of these 8 elements and you call this set as power set of A. So I think you follow because text. Yeah, tell me.
Sir, under D you wrote on something, sir. What is that, sir?
Sorry,
under D. Under D option.
Under this is and. This is and. So on. And so on means what? See, you have to go on layer. 3 element subset. It is okay for now our example what I wrote 1, 2, 3. So suppose if the set A has got suppose A, B, C, D, E, then you have to go till 5 element subset. That's why I said and so on. And the set A element. So until all elements are exhausted, like we stopped here with 3 element subset. Why? 1, 2, 3, 3 element once you collect, it is exhausted because it is already A. You got the full set A. So we stop there and make a listing of singleton. And then all the, empty set and then all the singletons together. Singletons, yes. They are together. And then go for all the pairing together. And then finally the 3 element subset A itself. But if you count, now try to count how many sets are inside the power set. Every element is a set. So that was the statement in NCERT. Here every element of power set of A is a set. So this is what you have to observe. Keep in mind. But what is the number of elements? What can we say about number of elements? When I say number of elements in power set, it automatically implies total number of sets in power set. How many are there? Can you count? Empty is 1, singletons 3, 2 element subset 3, 3 element subset 1. So it goes by 1 plus 3 plus 3 plus 1. That made 8. That makes the whole thing 8. What is the 8? What is the 8? What is the number of elements in A? What is the number of elements in A? 3. Because A, our example we took is A 1, 2, 3 only. Number of elements in A, 3. So what is the connection between this 3 and 8? So the number of elements in power set of A can be calculated as 2 power 3. So that is what makes the total 8. That's what makes the total 8. Everybody, how? Because you had 3 elements here, the result was 8. So can we make a guessing what will happen if there are 4 elements? What will happen if there are 4 elements? Set A contains, let us not even say set A. Let me call set B. Let us say A, B, C and D. Now what will happen? It will go by the same formula. Then the number of elements in power set of B will become 2 raised to 4. And what is 4? The number of elements in B, which is 4. And you come to the understanding that there are 16. So when you see here, it is just 4. But when you want to make a list of the power set B, you will have to produce 16 elements, and every element is a set in power set. So 16 set create panna. Are you understanding?
So it will be set or subset, sir?
Set of subsets. I don't understand what is set or subset. Our set is a set made of all subsets. Set of all subsets. It is the power set.
Yes.
So you have to think of all possible subsets. That's why we are going in order. 0 element subset, 1 element subset, 2 element subset, 3 element subset. So B has 4 up, you go till 4 element subset. The 4 element subset will be B itself. The first one is always empty set. In between you have to understand. Create one. So if you want to make a listing of power set of B, then yes, singleton, I'm sorry, making a mistake, okay, empty. Singleton is easy. A alone can be converted, B alone can be made a set, C alone can be made a set, similarly D alone. But how many pairing possible? 2 element subset means pair of elements. How many pairing you think it is possible? You will go on trying A, B, then B, C, then C, D. You will not know. Exhaust. Panyacha, Ilya, Abdin. Before you exhaust counting, you may get exhausted. So how to make a count? When there are 4, I want to count how many 2-member subsets, 2-element subsets are possible. I'll give you a shortcut again. You know Raghunathan has shortcut for everything. 2. Okay, so make a fraction, write 1 into 2 in denominator, write 4 into 3 in numerator. என்ன பண்ணிருக்கிறோம்? What is the number of sets in
Can I repeat it again, sir?
Yeah, number of elements in the set, that is 4. So numerator, you go by descending order. 1 into 2. Denominator, you write ascending order. Ascending order. What ascending order, descending order? Descending order begins with the 4. Ascending order always begins at 1. But how many factor? 2. How many you are picking up? எவ்வளவு பிக் பண்றேன்? 2 பிக் பண்றடா. ரெண்டு நம்பர் தான் எழுதணும். Numerator 2 number, denominator 2 number. So I want to pick 3. அப்ப numerator 3 numbers, denominator 3 numbers. That is the shortcut. So try this. What happens? Up you will have 6. You have to come up with 6 sets. Either 2 member. 2 member. Appo you know at least 6 எழுதணும் தெரியும். Yeah, A comma B. Then see, this is the order. A comma C. A comma D. Then it is B comma C. B comma D. Then comes C comma D. See, I have followed a very rigid discipline. Or first of all, I should know how many are there. How to do it? I told you a shortcut is there to make the counting. Shortcut. Even for divisors of a number, after prime factorization, I told you there is a method to count. Now for counting how many member subsets are there, yeah, there is a method how to count. This is a method. Yeah, you have to create a fraction, create numerator, denominator. Numerator you start counting in descending order, this in ascending order in denominator. As descending starts from the number of elements in the set, and here it starts at 1. Ethana member that is the number that decides the number of factors you write. Okay, so 6. But when I start picking up, I am having a discipline. So A, B, I have written Alagoni. Then A, C, then A, D. It's something like distributive law. Properly. Then you won't miss out. Then comes
Yes,
B,
sir.
C. Then start with second. First element will start with B. Then B and C. B and D. Suppose if one more is there, go for that. Already you completed 5. The last one will be C with D. 6 got over. So this is the discipline you follow. That means start with any element, go forward only, keep going forward. There's no question of coming behind. Min vache kala pin vekka maatom. So appiye poganum. Then second, start from second, then go with third, go with the fourth, go with the, like that. Ipdiye pannitrundha you get fantastic. Always you will get correct answer, both while listing also, in counting also. Counting procedure, I have told you the shortcut formula. For example, is it working for the previous sum? Out of 3, for example, 1, 2, 3, there are only 3. Now out of which I want to make pairing. 2 member subset I want to make. How do you do? Create a fraction, start descending order, start ascending order. Ethana number எழுதணும்? 2 number தான் நீங்க எழுதணும். அப்ப descending order is 3 into 2. Ascending order is 1 into 2. So what is the answer? 3. So 3 pair only. What are the 3 pair? You got it now. 1, 2, 1, 3, 2, 3. So this method will always give you the correct numbers. Okay, we'll quickly, time is up. We will quickly complete this power set for B and we will wind up. Cherikana. So 2-member subsets over. Now the 3-element subset, how many will be there? Same way, descending order, ascending order, 4 and 3 and 2, 1 and 2 and 3. So 4 subset. What are the 4 subsets? How can you say the subset? A, B, C. Then distribute.
A, C, D.
Very good. A, C, D. Don't move away from A until you reach D. Then you go to
B, C, D.
A, illada, A, B, C, A, C, D, one more A left over. I'm sorry.
A, B, D.
A, B, D. A, B, D. Then you start B, C, D for subsets containing 3 members. It is exhausted. That's 4 member. 4 member is B itself, A, B, C, D totally. That is B itself. Now it is completed. When you give the counting, it is 16. Null, singleton, 2 member, 3 member, 4 member. So it is 16. Yeah. So this is the arrangement. Fine. So this is a lot you have learned, and please remember, take care to remember. And one more, as I told you, that's one concept universal, and we'll go to the exercise. Thank you.